Hello everyone, welcome to my YouTube class. In this video, we are going to talk about the Sieve of Eratosthenes algorithm. Now this algorithm is used to generate the prime number stellium. It is used to generate the prime numbers. And we know that this is the theorem. The least prime factor of a number is less than or equal square root of the given number. Now say for example, we want to generate the prime number still 40. Generate means what? Prime numbers till 40 are 2, 3, 5, 7, 11, 13, 17, 19 and so on, 23, 27, 29, 31, 33, 37. These are the prime numbers till 40 and we want to generate it. Now we take the array of the size say 40. Why 40? Because I have said here the value of n to be 40. I have said here the value of n to be 40. We take the array of size n plus 1 till 40. Now why it is n plus 1? Because the array index starts from the index 0. Now what we do after we create the array, we initialize the array. The first step is you initialize the array. Now here we are not reading the array. User cannot fill the value like 10, 20, 30, 40. No. Here we will initialize the array. Now what we will initialize the array? Now at index 0 we will initialize with 0. At index 1 we will initialize it with 1, at index 2 it is 2, at index 3 the value is 3, at index 4 the value is 4, at index 5 the value is 5 and so on. We fill the complete array and so on we fill the complete array. Is that okay? Now see here we are filling the complete array. And so on up to we fill the complete array till the value 40. Now we know that 0 and 1 are neither prime nor composite. Therefore, we do not consider these values. And we know that the prime number starts from 2. And there is a theorem, the least prime factor of a number is less than or equal to square root of number. Now what is square root of 40? Square root of 40 is 6 point something and we take the integer value which is 6. And we take the integer value which is 6. Now 6 is over here. 6 is over here. Now start with the number 2. Now this is the value 2. We know that all the multiples of 2 cannot be the prime number. Therefore, where are the multiples of 2 are found? Now this is the multiple of 2. Make it as 0. Because it cannot be a prime number. Now this is the multiple of 2, make it as 0. Multiple of 2, make it as 0. Multiple of 2, make it as 0. Now this is all the multiples of 2 till 40. You make the numbers to be 0. You make the numbers to be 0. Is that okay? All the multiples of 2. These are the multiples of 2 that I am marking. Next multiple is 28, 30, 32 you make it as 0, 34 you make it as 0, 36 you make it as 0, 38 is 0 and 40 is 0. Now these cannot be the prime numbers. Now continue again. Now the multiples of 2 are done. Now take the multiples of 3. Now the multiples of, take the next non-zero entry. Now which is the next non-zero entry? It is 3. We are over here. The next non-zero entry is 3. Make all the multiples of 3 as 0. Now what are the multiples of 3? 6 which is already 0. 9 make it as 0. 12 it is already 0. 15 make it as 0. 18 is already 0. Make 21 as 0. 24 is already 0. Make 27 as 0. Okay, 30 is already 0. Make 33 as 0. 36 is already 0, make 39 as 0. Now whatever they are 0, they cannot be the prime numbers. Is it done? Now there is no entry called as 42, we leave it. Next, again go to the next non-zero number. Now the next number is 0, therefore we leave it. We leave it because it's not a prime number. Take the next non-zero number. Now what is the next non-zero number here? 5. Make all the multiples of 5 as 0. Now 10 which is already 0. 15 which is already 0, 20 which is already 0, but 25 make it as 0. Next is 30 already 0, make 35 as 0. Make 35 as 0. Take the next non-zero number. What is the next non-zero number? 7. But we know that the least prime factor of a number is less than or equal to square root of number. That means I need to do the procedure only till 6. Now I have reached 7. I stop here. Now apart from 0 and 1, whatever are there in the array which are non-zero, they are the prime numbers. Now 2 is a non-zero number, therefore it is a prime. 3 is a prime, but it is 0, leave it. 5 is a prime because it is non-zero. 7 is a prime because it is non-zero. 11 is a prime, it is non-zero. 13, 17, 19, 23, 29, 31, 37. These are the prime numbers that we have generated till 40. Are you getting it? Very simple. What we do? First we initialize the array. Then we use this theorem. The least prime factor of a number is less than or equal to square root of the number. Now square root of 40 is 6 point something. We take the integral value. That means till 6, starting from 2. Now start with 2, make all the multiples of 2 as 0. Take the next non-zero entry, make the multiples of 3 as 0. Take the next non-zero entry, it is 5. Make the multiples of 5 as 0. Take the next non-zero entry, it is 7. But 7 is greater than 6. We stop the procedure. At the end, whatever the entries are there in the array which are non-zero, they are the prime numbers till the 40, till n. Is that okay? This is how the sieve of Eratosthenes algorithm is used to generate prime numbers till n. I hope you have understood this. Please pause the video and write down whatever it is there, and you also try to generate prime numbers till 100. Draw this table of an array from 0 to 100 and try to do the procedure to print all the prime numbers from 0 to 100. Is that okay? Thank you. Next we will see how do we write the program for the same. Let us write the program for sieve algorithm. Now we declare an array int a of 1000. This is int a of 1000 from 0 to 999. And you have to read the value of n saying that till what you want to generate the prime numbers. Say for example, we want to generate prime numbers till 30 and let the value of n be 30. Now here again you pause the video and try to write down program yourself. Now say me, what is the next thing I should do? I should initialize this array. And how do I initialize the array? You should not read the array, you should initialize the array. How do you initialize the array? You say for I is equal 0. Now if the value of I is 30, till 30 you have to go with. Hence I say I is less than or equal to n I plus plus. Now if the value of I is 0, what you need to store here? What you need to store here? You need to store 0. If the value of I is 1, it is 1. In general, what do you store at a of I? A of 0 is 0. A of 1 is 1, and in general what you write, a of I gets the value of I. In general you write a of I gets the value of I. Therefore I say here a of I gets the value of I. Now initially I is 0, a of 0 is 0, I plus plus 1, a of 1 is 1, I plus plus 2, a of 2 is 2, so on, so on, so on. Each and every number is being initialized. Is that okay? Each and every number is being initialized. Suppose the value of n is 30. 28, I plus plus 29, a of 29 equal 29, I plus plus 30, 30 less than or equal to 30 is true, a of 30 is equal 30, I plus plus 31, 31 less than or equal 30 is false. You come out of this loop and you see that the array is initialized. A of I is equal I. Now after you initialize this array, I need to apply sieve algorithm on this array and get all the prime numbers. Therefore, let us write one function called as sieve. Let us write one function called as sieve. Now you want to generate prime numbers and store Where? In this array A. And how many array elements are there? There are n plus 1 array elements, or I can say A of n. Now be very clear while writing in Sieve algorithm, less than or equal n, because the value of n is 30. Because the value of n is 30. Now what should be the return type of the function and all? We will see it. Now this is in the main scope. Array name is A. Let the address of this be say 1000. This will be 1004 and so on. You know it. And let me write the Sieve algorithm. I say void Sieve. What is the first parameter? Integer one dimensional array. You have to write the appropriate prototype for all the functions that we have used it. And the next parameter is integer n. And the next parameter is integer n. Is it okay till now? I hope there should not be any difficulties. Now in this array, first what we do, we start from the entry number 2 and we go till the square root of 30. Now what is square root of 30? It is 5 point something, therefore we go till 5. That is 2, 3, 4 and 5 and we get the answer. Now what we write over here, I say int I, and any other variables are required, we will declare it. The value of I should start from 2. Why not from 0 and 1? Because 0 and 1 are neither prime nor composite. Therefore, I write here the value of I gets from 2. Till what? Till square root of n. Are you getting it? Why square root of n? Because the least prime factor of a number is less than or equal square root of n. Hence, I say I is less than or equal square root of n. And appropriately say math.h. And I write here I plus plus. Now what to do and how to do? Yes, just observe here. Now the value of I is 2. Now if the value of I is 2, what is stored at the second index? It is also 2. It is also 2, right? And let me say x is equal to A of I. Let me say x equal to A of I. And now the value of I is 2. What will be the value of x? The value of x will be 2. Needless to say. And why we are doing this here? X is equal to A of I. Now the value of x is 2. Now you say me the multiple of 2 will be found after how many steps? Where is the next multiple of 2 is found? At 4. Where is the next multiple of 2 is found? At 4. Where is the next multiple of 2 is found? At 6. Next multiple of 2 at 8. Next multiple of 2 at 10. Next multiple of 2 at 12. Next multiple of 2 at 14. That means after every 2 places you will find the multiple of 2. That means after every x places I will find the multiple of 2. Is it okay? Now that means I will find multiple of 2 after 2 places. Therefore what do I write it? For j is equal to the next multiple. How do you say the next multiple? 2 1 ja 2, 2 2 ja 4. That means this is 2 multiplied by x. It is 2 multiplied by x because the next multiple is found at 2 into x, which is 4. Had the value of x been 3, had the value of x been 3, where is the next multiple of 3 is found? At index 6. And how do you get 6? 2 into 3 is 6. 1 1 ja 1, 1 2 ja 2. The next multiple that you get is 2 only. Therefore, you say multiple by 2. You say multiple by 2. Therefore, it is 2. 2 into x. X is 2, right? 2 into 2 is 4. That means at index 4, you find the next multiple. And till where I need to go? Till the value of 30 I need to go. Hence, I say j less than or equal to n. What should be the updation? We will see it in some time. And what I need to do? Now what is the value of j? The value of j is 2 into x. 2 into 2 is 4. Now at a of 4, I need to make this value as what? 0. Hence, what do we write over here? A of j is equal 0. Hence, what do we write over here? A of j is equal 0. Now a of 4 is 0. Now next time, the multiple is found after 2 steps, right? That means the value of j from 4 has to become 6. And how do you get 6? 4 plus 2 is 6. That means j is equal to j plus x. That is what I write. J is equal to j plus x. Now 4 plus 2 is what? 6. Again go back. 6 less than or equal to 30. Yes. A of 6 is equal to 0. Yes. A of 6 is 0. Again you say j is j plus 2. 6 plus 2 is what? 8. 8 less than or equal to 30 is true. A of 8 is 0. J is equal to j plus 2. j plus x, which is 10. 10 less than or equal to 30 is true. A of 10 is equal to 0. Again, j plus x, 10 plus 2 is 12. 12 less than or equal to 30 is true. A of 12 is equal to 0. Now this is A of 12 is equal to 0. J is j plus x. 12 plus 2. What is 12 plus 2? 14. 14 less than or equal to 30 is true. And you say A of 14 is equal to 0. J is j plus x. 14 plus 2 is 16. Are you getting it? A of 16 is equal to 0. 16 plus 2 is 18. A of 18 is equal 0. So on up to A of 20 will become 0. 22 will become 0. 24 will become 0. 26, 28. Okay. Now the value of j is 28. 28 plus 2 is 30. Now check here. 30 less than or equal to 30 is true. A of 30 is equal 0. J plus x. 30 plus 2 is 32. 32 less than or equal to 30 is false. You come out of this loop and you see that all the multiples of 2 have become 0. Is it okay? Now, after they have become 0, you have to go to the next non-zero entry. Hence, you say I plus plus. Now, the value of I will become 3. X equal to A of I. Now, A of I means A of 3. And what is A of 3? A of 3 is 3. Now, where is the next multiple of 3 is found? At index x. Therefore, I say 2 into x. Now, you might have understood why 2 into x. J is 2 into x. Now, what is 2 into 3? 2 into 3 is 6. 6 less than or equal to 30. Yes, A of 6 is 0. Now, it is 0. Again, you are storing 0. It doesn't make any difference for me. J, now where is the next multiple of 2 is found? 3 is found at index 9. That means after 3 places. Therefore, we say j plus x, 6 plus 3. And what is 6 plus 3? It is 9. And you say A of 9 is 0. Again, j plus x, 9 plus 3. What is 9 plus 3? 12. 12 less than or equal to 30 is true. A of 12 equal to 0. Again, j plus x, 12 plus 3 is 15. 15 less than or equal to 30 is true. A of 15 is equal to 0. Again, 15 plus 3 is 18. A of 18 is 0. 18 plus 3 is 21. A of 21 will become 0. Similarly, 24 is already 0. 27 will become 0. Now, the value of j is 27. 27 plus 3 is 30. 30 less than or equal to 30 is true. A of 30 is equal to 0. Again, you say 30 plus 3 is 33. 33 less than or equal to 30 is false. You come out of this loop and again you take the next non-zero number and you say I plus plus. The value of I will become 4. X equal to A of 4. Now what is A of 4? Say me, what is A of 4? 0. Now, will you take this entry and make all the multiples of 0 as 0? You will never reach anything. Right? And if you do this, 2 into 0 is 0. Are you getting it? Therefore, this has to be done only if the value of x is not equal to 0. This inner for loop has to be executed only if the value of x is not equal 0. Now, what is the value of x? 0. 0 not equal 0 is false. Do not execute this. Again, you say I plus plus. The value of I will become 5. 5 less than or equal to square root of 30. Yes, it is true. X equal to A of 5. Now, what is the A of 5? A of 5 is 5. Where is the next multiple of 5 is found? At index 10. Therefore, you say j is equal to 2 into x. 2 into 5 is 10. 10 less than or equal to 30. Yes, you make A of 10 as 0, which is already 0. J is j plus x. 10 plus 5. What is 10 plus 5? 15. 15 less than or equal to 30 is true. You make A of 15 as 0, which is already 0. Again, if you make, nothing will happen. J is j plus x. 15 plus 5. What is 15 plus 5? 20. You make A of 20 as 0. Again, j is j plus x. 20 plus 5 is 25. 25 less than or equal to 30 is true. And you make A of 25 as 0. J is j plus x. 25 plus 5 is 30. 30 less than or equal to 30 is true. You make A of 30 as also true. J is j plus x. 30 plus 5 is 35. 35 less than or equal to 30 is false. You come out of this for loop. Right. Again, you say I plus plus. The value of I becomes 6. 6 less than or equal to 5 is false. You come out. The closing bracket of the function is taken as return and declare the appropriate variables, any other variables that I have declared. Now, after you return, you come back to the main function. We know that arrays are passed to the function by address. any modification done of the arrays over here will be reflected back in the calling function. Already I have explained. And this is how the array will look like. Now what I need to do? I need to print all the non-zero entries of the array apart from 0 and 1. Do not write the display array function. What does display array function will do? It will display the complete array. Do I want to display the complete array? No, I want to display only those elements which are not 0. Hence, how do I write it? How do I write it? We say for I is equal to 2. Why I is equal to 2? Because 0 and 1 are neither composite neither prime. And we say I is less than or equal to n, I plus plus. Now, say me, will I display a of 2? Yes, sir. Will I display a of 3? Yes. Will I display a of 4? No. Why? Because it is 0. Hence, how do you write this? We say if, say me, a of I is not equal 0. I say if a of I not equal 0, then what I write, you can just write if a of I, you know that, then what shall I write over here? I say printf %d comma a of I comma a of I. I will just trace it for one time, and this is return 0 and end of the main. Now I is 2, a of 2 is 2 not equal to 0, it will display 2. I plus plus 3, a of 3 not equal to 0, yes, it will display 3. I plus plus 4, a of 4 is 0, 0 not equal 0 is false, it won't display 0, and so on. It displays all the prime numbers till n. Is that okay? I hope you have understood this question. Now, the variant of this question will be an assignment. Please note down. Now, you need to say if a number can be expressed as sum of two primes. What do I mean by this? Say for example, the value of n is 34. Now, can I express 34 as sum of two primes? Yes. And how can I express it as 33 plus 31? Now, 3 is a prime, 31 is a prime. Therefore, these 34 can be expressed as sum of two primes. Therefore, 34 can be expressed as what? Sum of two primes. I hope you are getting it. Now, if I say n is equal to 25, can you express 25 as sum of two primes? Can you express 25 as sum of two primes? If you say 13 plus 12, 13 is prime, but 12 is not prime. If you say 24 plus 1, 24 is not prime and 1 is neither prime nor composite. Now, how you can write this 25 as? You can say 2 plus 23, which is 25. Therefore, this 25 can also be expressed as sum of two primes. Now, given a number, you have to check whether that number can be expressed as sum of two primes or not. Now, I will just give the introduction for that. You have to do yourself. Now, if I say n is equal to 25, what you do? Generate prime numbers till 25. Now, these are the prime numbers till 25, from 2 till 25. What we will do? Yes, can anyone say what we will do? We will take a pointer over here. Right? We will start from here. Now, what is the value of I? The value of I is 2. Now, it is a non-zero number. Therefore, it is a prime. Now, if 2 is prime, to make it as 25, what should be the other prime? It should be 23, right? That is 25 minus 2 should be the other prime. Now, go to index 23. Do you find 23 over here? Yes. Therefore, 25 can be expressed as sum of two primes. Therefore, 25 can be expressed as sum of two primes. Is that okay? Now, let me do it for 34. Now, this is 31, which the value will be 31. 32, the index will be 0 because it's not a prime. 33, it will be 0. 34, it will be 0. Now, you generate all the primes from 0 to 34. Now, again you start from 2. Now, 2 is a prime. Now, to make sum as 34, what should be the other number? 32. Now, is 32 a prime? No. Now, therefore, go to the next number. What is the next number? 3. Now, if 3 is a prime, what should be the other number to make it as 34? 31. Is 31 a prime? Yes. Therefore, 34 can be expressed as sum of two primes. Therefore, 34 can be expressed as what? Sum of two primes. Now, if I take n is equal to 6. Now, you can say 3 plus 3 as a prime. No, the two numbers should not be same. Now, how can you write 6 as the sum of two numbers? How can you write? You can make it as 6 plus 0, but we know that 0 is neither prime nor composite. We can make it as 5 plus 1. We know that this is neither prime nor composite. You can make it as 4 plus 2. 2 is prime, but 4 is not prime. You can write it as 3 plus 3, but I said that these 3 are prime, no doubt, but these 2 should be unique. The next one is what? Again 4 plus 2, 5 plus 1 and 0 plus 6. Therefore, 6 cannot be expressed as sum of 2 primes. Now, how do we verify this? Generate all the prime numbers till 6. Now, these are the prime numbers till 6. This is very important question. Generate all the prime numbers till 6. Now, you have generated all the prime numbers till 6. Is that okay? Now, you take 2. First, you start from 2. Now, if 2 is prime, what should be the other number? Other number should be 4. Then only you will get 6. Is 4 a prime? No. Leave it. Next, you go to 3. Now, what should be the other number? 3. And I said that both the numbers cannot be same. Leave it. Go to the next number 4. 4 itself is not a prime number. Leave it. Next, go to the next number 5. If you go to 5, you cannot take 0 and 1 because 0 and 1 are neither prime nor composite. Next, you go to 6. If you take 6, you get the next number as 0, which is neither prime nor composite. Therefore, 6 cannot be expressed as sum of 2 primes. This is an assignment. Please do it. How do we express a number as sum of 2 primes? Thank you friends for watching this video, and in the next video, we will see some other question. Thank you.